Now I have this new set of data, quarterly data of trips made by or overnight trips made by Australians in probably million or billion miles. But we need to forecast that. So I have the data from 1998 to 2017, and I need forecast from 2018 to 2020. So the first thing we do whenever we get data is to plot it. So I select this data, and an important part here, the quarter column is text. It's not scatter plot. It's not numeric, so I can't use scatter plot, but I'll have to use the line chart. Remember, when both data sets are numeric, we can use scatter plots. But when one is text or string, we use these line plots. I use line plots. Yeah, I can see some spikes, but there's a vacant area. So I'm going to try and remove it by making this axis close to the lower end. I'll make it close to 9 if I or 7.5. So yeah. And this I'll probably 13.5 is fine. All right, so now if I can look at this data trips, there is some kind of seasonality, right? So every first quarter, it sort of goes up. Quarter one, again, it's going up. Every first quarter, it's sort of going up. So I can assume that I have quarterly seasonality and start modeling and creating my sheet. But that's not a great method because who knows, there is something else. So one way to do it is we start by assuming all kinds of seasonality. Let's assume we have seasonality every alternate months. So if that's the case, the first and the third and the fifth and the seventh month would be high. Second, fourth, sixth, eighth, and so on, all those months would be very low. So if I find correlation between first, third, seventh, and second, fourth, I should see some kind of a high correlation, right? So I try to find a correlation with a lag of 2 and say, what do I see? Do I see a high correlation? If I see high correlation, that means there is a seasonality every alternate month. So I take that data from the third month and paste it here. And then I'm going to try and find the correlation at lag 2, which is equal to correlation between this data here, and I unselected some data because I only had so much data in lag 2, and wonderful. So there is negative correlation, and remember the highest correlation is ideally closer to 1 if it's a positive correlation, but this is 0.16, it's very low. So maybe I have seasonality every third month. So I try to find lag 3. And the same thing, paste it here, and then I'll try to find the correlation for the lag 3. So every third month I have a seasonality. That's my assumption. I don't know. And I select my data, and then I again reduce because I have corresponding the other side. I only have so much data. Perfect. 0.07, not even close to 1. So there's definitely not correlation at lag 3. Lag 4, which I'm saying maybe first quarter of the month of 1998 is correlated to first quarter of 1999, and all the quarters are correlated. So I will try to check that. And so now I'm testing if the seasonality is quarterly. Lag 4 is equal to correl. That's the Excel formula. Ta-ta-ta. I only have so much data, so I reduce the data there. Oh, 0.87, which is very close to 1. So I know that there is a good chance that I have quarterly seasonality. Very good chance. Now, yeah, you can, do I expect you to do this for every, 4, 5, 6? Well, yeah, you could. It's not too difficult. But we have a better method. There are online tools which support us by giving us these quarterly coefficients. Now, one of them is this particular data set tool. The link would be in the description, which calculates partial autocorrelation function, which is similar to correlation, not exactly. I have already entered our data here, and I'm going to ask it to give us a chart. I computed, and it computed it that the second correlation is negative, just like we have here, negative 0.16. It has negative 0.15. This is very low, 0.08, just like we had the correlation. This fourth quarter, the fourth lag, is 0.789, which is high. So it tells us and indicates us that we have quarterly correlation. So there's something about quarters. Some quarters it goes up, some quarters it comes down. But yeah, we use this information, we go back to our exponential smoothing application, and this time I want a CSV. I put the data, seasonal periods is 4. Now seasonality matters. So I've asked it to calculate seasonality 4, triple exponential smoothing. I'm going to select additive, and I want forecast for the next 12 periods, and I ask it to compute. It creates a CSV file, which it'll open. Here is my CSV file. It has the forecast, the fitted values right here. I create space. I'm going to move this out a little bit by inserting blanks. So first I get the fitted value. Like I've been saying, the values of past data are not supposed to be called forecasts. They are fitted values. I select these fitted values and paste them from 5th, because if you see here, they start from the 5th month. The first 4 months are based on assumptions. So you have the fitted values, and now I need the forecast. So I go back to our sheets. It has the forecast starting here, and it even has the confidence interval that 95% the forecasts are going to be between those values. And then I paste it here. La-la. This is my forecast, which has calculated, taken in account seasonality, and you can actually plot these values to see that if it has configured the seasonality, which is what I am going to do. So I select this data, entire thing, and make a line chart. And if you look at that, the orange is the forecast, which sort of mirrors the actual, which is the blue hidden behind the orange. And even in the future, the orange does show seasonality. So whenever we have random plus trend and season, the method is triple exponential smoothing, which will configure the seasonality